Attentive Item2Vec, Neural Attentive User Representations. This one is from Barkan, Katsiularu, Katz, Noam Koenigstein. Microsoft, Bar-Lan University, Technion, Tel Aviv University. Abstract. Factorization methods for recommender systems tend to represent users as a single latent vector. However, user behavior and interests may change in the context of the recommendations that are presented to the user. For example, in case of movie recommendations, it is usually true that the earlier user data is less informative than more recent data. However, it is possible that a certain early movie may become suddenly more relevant in presence of popular sequel movie. This is just a single example of variety of possible dynamically altering user interests in presence of a potential new recommendation. In this work, we present Attentive Item2Vec, a novel attentive version of Item2Vec. Item2Vec employs context target attention mechanism in order to learn and capture different characteristics of users' behavior context with respect to a potential recommended item target. The attentive context target mechanism enables a final neural attentive user representations. We demonstrate the effectiveness of Item2Vec on several datasets where it is shown to outperform baselines. Okay, so where we have a key contribution of Attentive Item2Vec arises from its novel neural attentive user representations that dynamically adjust the presence of different target item recommendations. First, Attentive Item2Vec extracts attentive context target representations, each designed to capture different user behavior, the potential target item recommendation. These attentive context target representations are then fed into a secondary network that chooses the most relevant user characteristics and constructs final attentive user vector. This vector constitutes the dynamic representation of that user, the specific target item recommendation. Attentive Item2Vec employs a novel context target attention mechanism to form a final neural attentive user representation that is subsequently used for scoring the similarity between the user and the potential target item recommendation. Different from 18, Attentive Item2Vec does not employ self-attention but context target attention, where the context is the historical items and the target is the potential item recommendation. In addition, Attentive Item2Vec scores the attention between the target item to the context historical items by cosine similarity function instead of scale dot product. Lastly, Attentive Item2Vec learns a neural scoring function that for scoring the similarity between the attentive user and item vectors. Okay, conclusion. This work presents Attentive Item2Vec, a novel attentive version of Item2Vec that employs context target attention mechanism. Attentive Item2Vec attends the historical context items consumed by user to a potential target item recommendation and produces neural attentive user representations. The effectiveness of Attentive Item2Vec is demonstrated on several datasets where it is shown to outperform both Item2Vec and NCF. NCF is Neural Collaborative Filtering Model. Okay, so that was the spice of the paper. I will go a little bit more detail, although I don't have that much time today. Alright, so yeah, as well, unsubscribe and dislike. Thank you very much. Okay, so what they do here is interaction. Item2Vec is an increasingly popular embedding model for learning item representations based on or collaborative filtering data. It builds upon the Item2Vec and represents attentive item. This work builds upon Attentive and represents Attentive Item2Vec, a model that learns neural attentive user representations that dynamically change in the presence of different potential items recommendations. Traditional collaborative filtering methods, such as matrix factorization models, represent users as a single user vector that remains static regardless of the potential recommendations being considered. However, users' interests and behavior form a context that may dynamically change in presence of different recommended target items. Consider the following example. A user may be generally interested in popular mainstream action movies and less interested in niche, less popular action movies. That user may also have a minor interest in specific historical era, for example, Roman Empire and US Civil War. And as a result, she has watched some documentaries on the subject a while back. These documentaries are generally not very relevant to her current interests. However, in presence of a niche, not very popular movie about the empire, the old events become much more relevant. The However, in presence of a niche movie about Roman Empire, her old events become okay. A key contribution of Attentive Item2Vec arises from its novel neural attentive representation that dynamically adjusts in presence of different item recommendations. First, Item2Vec express attentive context target representations is designed to capture different users' behavior. So first, context target representation designed to capture different users. Potential target item recommendation. These attentive context target representations are then fed into the secondary network that chooses the most relevant user characteristics and construct the final attentive user vector. This vector constitutes the dynamic representations of that user, the specific target item recommendation. Attention in neural networks allows modeling intersequence dependencies without regard to the position in the sequence. Initially, this was used in conjunction with LLMs for NLP tasks in 14 and 15. For session-based recommendations and for multi-view recommendation. However, a recent trend in NLP community is to utilize attention mechanism directly on the input embeddings instead of RNNs. This setup was successfully employed by Vashwani et al. In 18. They probably mean this transformer architecture, where it was shown to produce superior results on multiple machine translation tasks. Actually, let me check if they mean the transformer. What the hell? I cannot scroll, man. Okay, 18, Vashvana says here, attention is all you need. Yeah, they definitely mean transformer. Attention Item2Vec employs novel context static and attention mechanism to form final neural attentive user representation. This is subsequently used for scaling similarity between the user and the potential target item recommendation. Different from 18, Attentive does not employ self-attention, but context-target attention, where the context is the user historical items and the target is the potential item recommendation. Okay, so once more, would they use different context? Does not employ self-attention, but context-target attention, where the context is the user's items and the target is potential item recommendation. In addition, Attentive scores attention between the target item to the context historical item by cosine similarity function instead of scale dot product. Lastly, attention Attentive learns a neural scoring function that for scoring the similarity between the attentive user and item vectors. Attentive in addition scores the attention between the target item to the context historical items by cosine similarity function instead of the scale dot product. Lastly, Attentive learns a neural scoring function for scoring the similarity between the attentive user vectors. Further attempts for incorporating attention mechanism in the recommender system includes 4 and 5. However, these models average auxiliary content-based information about the items and hence can be seen as hybrid models rather than the pure collaborative filtering such as Attentive. The remainder of this paper is organized as follows. Okay, Attentive. In this section, we provide a brief overview of Attentive model, which serves as a basis for attention Attentive. They be a set of item identifiers. Each item is latent context target vectors. These latent vectors are estimated via implicit factorization of items co-occurrence matrix. Specifically, we represent user as a list of historical items that were co-consumed together. Okay, historical items that were co-consumed together. Okay, so it's considered the data set of single user where extension to multiple users is straightforward. The Attentive objective is to minimize loss function where there is okay, so they try to minimize loss function of sum of logarithms of conditional probability of item j condition on item I, where item j and item I guess are co-consumed, and this conditional probability is formed as follows. So they have the segment function as a I guess that's similarity, cosine similarity. So single function applied on cosine similarity, and then product of k in n, sigma of minus similarity from Li to k, where sigma let's say is some kind of sigmoid, and n is in I, is a subset of items that are sampled for I according to the unigram item distribution raised to the 0.5 power. The items are treated as a negative items. That is the items. Okay, so those are the items that were not consumed. In order to mitigate popularity bias, it come on collaborative again. Dataset further applied to subsampling procedure in which items that are not randomly discarded from the users according to the popularity. Attentive Item2Vec. So attentive. Okay, let me just finish that. Amount of sampling in training phase. Attentive learns set of context and target vectors by minimizing the loss function using stochastic gradient descent. In inference, the similarity is computed via cosine similarity. Okay. Okay, so instead of here, the similarity, they don't use similarity as a cosine, but instead they use, this direct dot product, but during inference they use cosine similarity. Okay, and Attentive Item2Vec differs from Item2Vec in several aspects. First, Item2Vec models the probability of the target item given all previous history, so optimizes different objective. Models the probability target given all previous history, hence optimize different objective. Secondly, employs Attentive Item2Vec AI2V employs softmax with negative sampling instead of skigram with negative sampling. That appears in equation 2. Yeah, that's one what I mentioned. For the Attentive Item2Vec employs a novel attention mechanism that learns to attend the context item with the user history according to their conception. Fourth, AI2V model similarity between the attentive user and candidate item vectors using neural scoring function, which is different than the dot product function in Item2Vec. Lastly, introduces a target bias which eliminates the need for subsampling procedure, which requires an additional hyperparameter tuning effort. Okay, I'm out of time. Thank you very much for listening. I will read the conclusion. This work presents AI2V novel attentive version of I2V, Attentive that employs context target attention mechanism. AI2V attends the historical context items concerned by the user to a potential target item recommendation and produces neural attentive user representation. The effectiveness of Attentive Item2Vec is demonstrated on several datasets where it is shown to outperform both Item2Vec and neural collaborative filtering. Okay, thank you very much. I hope you like it. Please dislike, unsubscribe, and thank you very much. See you next time. Bye bye.